On 7/8, now we're looking at having both factors with decimal points in them. The process is the same. In fact, in number 1, it's just a mental math fact. We have 3 times 6 is 18. We went over 1 decimal point here, 1 decimal point here. So we need to now go over 2 decimal points here, 1, 2, and our answer is going to be 0.18 or 18 hundredths, and we can add that 0 in front to make it more mathematical. Here we have our mental math of just 2 times 3 is 6. And I can just leave it like that for now, but then you have to be a little bit careful, because if you're going over 3 here and 1 here, you need to go over 4, and you need to make sure you're adding your zeros in this way. So if I have to go over 4, I go over 1, 2, 3, 4, and there's my decimal point. And this, all of these spaces here, these need to become zeros. And again, I can put that 0 in the front. What I could have done to begin with, so that I didn't have to think, oh my goodness, where do the zeros go? I could have gone through and said, 3 times 2 is 6, 3 times 0 is 0, 3 times 0 is 0, 3 times 0 is 0, and then counted over. And then I would have gone over 1, 2, 3, 4, and I wouldn't have had to think about making sure those zeros get in. I personally think this is faster, but if you're finding that you're making mistakes with your zeros, stick to doing it this way. Number 10 is the same thing, it just has decimals now. So I have 6 times 2 is 12, 3 times 2 is 6 plus 1 more is 7. I'm done with this now, so I'm going to add in my 0 as a placeholder. 8 times 6 is 48. 8 times 3 is 24, plus 4 is 28. I'm going to add, and I have 2952. I need to remember that this went over 2 decimal points, this went over 2 decimal places, so I add these two things, and I think, okay, this is going to go over 4, so I'm always going this way, 1, 2, 3, 4, and my decimal point is going to go there. If you thought about, if you prefer to be doing lattice, you have two two-digit numbers, because you don't need to worry about the zeros in the front in the ones place. So you can have your 36 and your 82, and then draw your lattice, and then don't worry about your decimal point right now. Go ahead and just multiply like you normally do. So you have 48 and you have 12. Done with that. 24 and 6. Okay, so I'm done with those. I add these together. 9, 2. Now I need to, if I rewrite my answer like I've asked you to do, and I think, okay, my first one had a decimal point here, so it had a decimal point over 1, 2. And this, it's kind of weird, so I might want to rewrite it on the side to see, oh, it's 1, 2 for a total of 4. 1, 2, 3, 4. So the lattice method still works. You just want to make sure you don't forget to put that decimal point in. Number 15 says the sunlit zone of the ocean has a depth of about 600 feet, meaning it goes down 600 feet. The dark zone, where there is no light at all, begins at 5 5/10 times, 5.5 times that depth. At what depth does the dark zone of the ocean begin? Our key word here that we're looking at is times. So it's saying it's 5.5 times 600 feet. So when you do your problem here, remember with multiplication, we don't need to line up those decimals. You can just do your multiplication problem like that. Number 16 says that Lauren has 9.9 meters of ribbon. She is cutting it into 100 equal pieces. Now they make this nice and easy for you because they're telling you what to do next. That is the same as multiplying 9.9 by 0.01. How long will each piece of ribbon be? Well, if we do the math here, we have 9, 9. I'm going to add some zeros because this goes over 1 and this goes over 2. So my answer goes over a total of 3. So if I multiply this, I have 0.099. So we could look at this as saying 0.099 meters, or if you look up here, we have millimeters, centimeters, decimeters, and meters. I could think if with meters, I go over 1, 2, 3 spots to get to millimeters, I could go over 1, 2, 3 spots and say that that's the same thing as 99 millimeters. The problem doesn't ask you to do that, but 99 millimeters is sure easier for me to visualize, or even 9.9 centimeters is easier for me to think about in my head than 0.099 meters. So any of these answers is correct because they are all the same. Number 17 is a mental math problem. It says a furlong is a unit of measure used in horse racing. Every year, horses race 10 furlongs in the Kentucky Derby. 1 furlong is equal to 0.125 mile. How long is the Kentucky Derby? Well, it just says the Kentucky Derby, is 10 furlongs. So we're going to say, okay, 1 furlong is 0.125, so all we need to do is take 0.125 times 10, which is mental math, because remember when we're multiplying by 10, the number is getting bigger. There's 1 0, so I need to move over 1 place. So I have 1.25 miles.